Welcome everyone to today's webinar, Techniques for Effective TI-Nspire Use in Mathematical Methods, brought to you by Texas Instruments Australia. My name is Frank Moyer, and what we're going to do today is look at some practical, straightforward tips to help you use your TI-Nspire efficiently when working on both routine and non-routine problems in class, and also school assessments, exams, and so on. So I'll be largely reinforcing some of the techniques that you may have seen earlier in webinars in terms 1 and 2. Just a reminder that there is a worksheet to accompany this, and it can be downloaded from the TI Australia Student Hangout, which is very simple to find, tistudents.wordpress.com. All right, so I'll start by looking at recommended settings and adjustments that you might need to make for particular problems. So to change settings, this is something that I'm sure that all users are familiar with, but probably the most intuitive way is to hit the on button or the home, number 5, and then number 2, document settings. Now, the default settings seem to work pretty well in methods most of the time. So float 6 seems to work most of the time, and we'll have a look at ways of changing the number of digits for various problems. Tab down, radians obviously rather than degrees. This is something that you need to be aware of if you're also doing further maths, the need to change between radians and degrees for the different subjects. And now the calculation mode, there is auto and there's exact, and I know that I've heard some discussion as to which is better. My recommendation is auto, and I'll explain why. Irrespective of what global settings you have, there will be some problems where you need to make adjustments, and you need to know how to deal with those particular situations. So I'll just go back to my current problem. All right, so in mathematical methods, the exams require exact answers unless otherwise stated. So the question might say, answer correct to 3 decimal places. Now, the auto mode gives exact answers if possible, otherwise it gives an approximation. Now, if auto mode gives an approximation, there is always a good reason, and we're going to have a look at some examples to see where that might happen. So the first example we're going to have a look at is solving log to the base e of x equals 4 minus x squared, and I'm going to solve that for x. And it gives me an approximate answer, and there's a little warning. Basically, the warning is just there to tell you that it's used an approximate method. So it is possible that there are additional solutions. In this case, there isn't. If you have a look at the graph, there is only the one. So why does it give the approximate answer rather than exact? So earlier on in this other document, I did the same calculation, but this time I used exact mode. And the calculation, when you solve log to the base e equals 4 minus x in exact mode, it just throws it back at you, slightly rearranged. The reason being that there is no exact algebraic solution. It's not like a simple quadratic equation where you can factorize, use the null factor law and come up with an exact algebraic solution. So there's a good reason why you get an approximate answer. Now, the other one is integrals involving things such as e to the minus x squared. Now, this was relevant if you were part of the previous webinar series. If you have a look at the last one in the previous series, we were looking at the normal distribution, and the probability function for normally distributed random variables involves e to the minus x squared, or at least it's a transformation of that. Now, if you do that in the auto mode, you get an approximate answer. If you do the same thing in exact mode, it just throws it back at you. The reason being that the antiderivative of e to the negative x squared is not itself a function. So therefore, it can't be, an exact answer doesn't exist, and therefore it does nothing. So that is where it can be problematic if you're in exact mode and you're not getting an answer. Now, you might have a situation where you've got a decimal in the question and you still need an exact answer. So for example, I've got 0.125 sine of 2x, and I want to substitute pi on 6 and pi on 12. Now note that if you're substituting more than one value in TI-Nspire, it needs to be in a list. So the list is in the curly brackets. Now, if you're in auto mode, you get those two answers for pi on 6 and pi on 12, one of which is they're both decimal answers. So as soon as TI-Nspire sees a decimal in the input, the output will be in decimal form. Now, a decimal answer may or may not be an exact answer. So in this case, the second answer is an exact answer, but the first one isn't. And you can see, you can tell that because when you take that value and paste it back into the entry line, you see that it's got additional decimal places. So that's a pretty good indication that it's an irrational number. So in a situation like this, if you're in auto mode, you might need to force exact mode. Now, rather than change the calculator settings to exact mode, you can just have force exact mode just for this calculation. One way you can do that is by going to the catalogue, so that's the big book symbol, and if you go to E, it takes you to the top of the E. If you press F, it takes you to the top of the F. From there, you can find exact. And you can also see the syntax down the bottom. So the syntax is just the expression, and you've got the option of putting in the tolerance. So exact, I'm going to grab this up, pardon me, grab that, press enter, and I've forced exact. Okay, so they are my recommended settings. There are times occasionally when you might have to force exact, and that's one way that you can do that. All right. So the other thing I'm going to look at is different ways of defining problems. Now, when defining functions, it's useful to, it can be useful to insert a new problem. Let's suppose that I defined f of x in this function here, in this problem here, f of x, and I'm going to assign, so the assign is control and the template button next to the 9, x squared, for example. Now, that is now defined in every page, or that will apply to every page in problem 1. So in page 1.9, if I hit the variable button, I see that, yes, f is there, and I can see that it's been defined here. But if I go to a new problem, if I insert a new problem, and how can I insert a new problem? I can go to Doc and Insert, which is number 4, and Problem, and then choose the type of page you want, whether in that problem you want to start with a calculator page, graphs page, or whatever. In this case, if I now hit the var button, because it's now problem 2, so I'm in problem 2, page 2, I can see that it's empty. So it's like someone has handed me a new calculator. Okay, so different ways. We've seen assign, how we can use the assign. The other way, of course, we can define a function. This is probably the one I use the least. Menu, actions, and define. And I'm going to grab this here. By the way, if you want to grab only part of something in the history, you can put the cursor at the end of it, hold the shift key, and then just arrow across and select the bit that you want. So if I now go to var, I see that F is defined. Pardon me, I should have forgot my X. So f of X is my definition. Now, another way that I can define is just by graphing the function. So 3 minus X, I could insert a graphs page, so Control I or Control Doc, graphs 3 minus X. And if I now go back to a calculator page, I see that I now have two variables, F and F1. F1 of X is 3 minus X. Of course, the other thing I can do is I could even wipe all that, so select that whole thing as I shift and arrow across, change that to G of X, overwrite it with G of X, equals 3 minus X, and I see that that will also graph the function. So I don't have to use F1 of X, F2 of X, F3 of X. And if I now go to G of X, I can see that G is bold, so it has been defined. That's also 3 minus X. All right, so we've seen three different ways of defining: the define, the graphing, or the assign. So the assign, remember, is the dot dot or the colon equals. So Control and the template button, and P of X has now also been defined. Now, I'm going to define H of T. Now, I want to store this list, pi on 3, pi on 2, and so on, in a list labelled A. So I'm going to take those values and I'm going to use the store. Now, the store, the define, the assign, essentially all do the same thing. But the store is Control and the var button. I'll store that as A, except, of course, because it's a list, I have to make sure that it's in curly brackets. So get the curly brackets and Control and var A and see whether it works now. So it does. So just a reminder that a list must be in curly brackets. So I could now have H of T given, so Control equals. Now the quickest way to get to the given is to then press the left arrow, takes you straight to the given, T equals A. We see that the A is bold because it's that whole list, and it's substituted all of those values. Okay, deleting a variable. Sometimes I no longer want that variable. My variable button might be, if I have a look at my list of variables here, it's getting quite crowded. If I want to delete a variable, there is a command called delete variable. So you go to the catalog, the big book, and D until you come across delete variable. There we go, delete var, and you can see that the syntax is just to put in the different variables. So in this case, if I want to delete A, select this, enter. So if I now press A, I see that it's no longer bold. It's no longer a defined variable. Okay. Now the other thing I want to have a look at is maths actions. Once you've defined a variable, or once you've inputted an expression or an equation, the maths actions and the context menu can be quite useful to save some time, reduce syntax, and to be prompted on other things that you might be able to do with that. So I'm going to start with f of x. So I've already defined f of x in problem 2. So f of x, and without pressing enter, I'm going to press control menu. That's the context menu. So the context menu is just a subset of the full menu, just for things that are relevant to this f of x. So what can I do? I can recall the function and get the graph. That's one thing I can do. And that's quite handy, having the graph there. If I want to separate that graph out, I can go to Doc and Page Layout, number 5. Now, I've got those two pages are grouped. If I want to ungroup them, it's 8. And I now see that I've ungrouped them. I've now got those as separate pages. Let's see some of the other things I might be able to do with the context menu. So without hitting enter, control menu, maths actions, so I can try to factor, complete the square, find zeros, and so on. And I've got the option of real factors, complex factors, which of course isn't relevant for methods, or rational factors. So I'm going to do real. And you can see that it's done the syntax for me. So that can be quite neat. Now, this also works with expressions, so it doesn't have to be something you've defined. So I've got this cubic expression here. So control menu, once again, I can see that there are things, it gives me a choice of things that I can do. If you have an equation, likewise, you can use maths action. So if I have that equal to 0, I'll see that the maths actions are slightly different. So this time I can have solve and so on. Because it's an equation I can solve, it's put all the syntax in for me. If I have the derivative of that expression, so I'm going to take this expression and I'm going to Control C to copy it. And this time I'm going to get the derivative of that expression. So the derivative, the quick way of getting the template is Shift minus. Remember, Shift plus for integral, Shift minus for derivative. X, I tab up to here, Control V. And this expression here, I can also use maths actions. So let's see what options. I've got the option of finding the zeros. So that's option 4. So put all the syntax in for me. So that's very handy because I very quickly got the x coordinates of the turning points of the graph of y equals that function. if I want to get the y coordinates, I didn't want that, I want this one here. I'll copy that one, paste it, given this list up here, except I forgot my x equals, and it's quite good with Nspire that if you make an error, it points it out to you. So it's very forgiving in that sense. So I've got the x and y coordinates of the stationary points. Okay. Now I'm going to skip some of these because I want to have a look at graphing with parameters such as h and k. So I've got this function x minus h squared plus k, and I'm going to put a domain restriction. Now, the quickest way to put a domain restriction in is using the given. So control equals, left arrow, given, and the domain restriction, yep, I want this here. X is greater than or equal to h minus 3. Now, the beauty of Nspire is, do I ask whether I want to create sliders for those? Yes, I do. And I can move those sliders. I can also change the settings. I can make them smaller so that they're spinners rather than sliders. I can move them around and so on. And this one here, to move, you can choose one, move it round, and I'm going to choose -4. Okay, so that's quite handy. And note that not only can the function have a parameter, but the domain can have the parameter in it as well. Now, relation graphing. So I want to graph the line x equals h minus 3. So let's go back to the entry line. Now, if you hit the back arrow, you see that you've got more options. So you can change to y, greater than, and so on. Down the bottom, you've got 6. So if I press the up arrow, it takes me to relation. And that's probably the quickest way of jumping to relation graphing. So now I can enter a relation which can either be a functional or non-functional relation. Now in this case, I want to put in the non-functional relation x equals h minus 3. And I also want to find the point of intersection of these two graphs, because that's the endpoint of the graph. So there's a number of ways I can do that. I can go through Analyze Graph. Now, Analyze Graph does have intersection, although I usually don't get points of intersection that way. We'll see why in just a minute. I prefer to do it using the geometry menu. But you can also do things like a minimum. If I wanted to find the minimum here, click the graph. It will give me the minimum for the parabola. Now, another way that I can get the turning points, the points of intersection, it's menu, geometry, you've got points and lines, and you've got intersection points. And the reason I prefer to use this method is that if there are multiple points of intersection, this method will give you all of the points of intersection at the one time. Now going to delete that line, or hide that. I don't want to delete it, I want to hide it. So you can just touch it and control menu, the context menu, and you've got an option there to hide. All right. Now the other thing I want to do is put in the line y equals x. So once again, I can do that in relation graphing, y equals x. And I also want to change the attributes of that because I want that as a dotted line. Now to change attributes, you just touch the line and control menu, the context menu, and you've got number 3 attributes. And you'll see the second one there, you've got the line style. I want to go from continuous to dotted. You can also have dashed and so on. All right, so the context menu, really useful. And finally, what I want to do is get the inverse relation to this function. So this function has the rule y equals f1 of x. So the inverse, I need to swap the x and the y. So instead of being y equals f1 of x, it's x equals f1, which I can either type in or get from the var menu. Oops, f1 of y. I see that I've got the inverse relation there. And as I change h, I can see the effect of the inverse. All right, so relation graphing can be quite powerful. Now, the other relation graphing I want to do is this graph here. So I'll just copy that and I'll add a graphs page. Now, the default, of course, is to have the function graphing. Now, different ways that you can change to relation. You can just use the go backwards and choose relation, or you can do control menu and that'll bring the graph entry edit, and relation is one of the options. Of course, the longest way, the one that the method that I rarely use, is you can go to menu, graph entry, edit there. So any of those methods will work. Okay, so I'm going to graph that relation. Now, if I don't like that color, you can just touch it. Control menu is the quick way of getting to changing any attributes, including line color, and I might change that to blue. All right. Now, I can also put a parameter there, so I could have that as R, for example. Do I want to create the slider? Yes, I do. But the default settings don't really suit me. So there's no point having a negative value. So I'll start at 0 and I'll go to 20 in steps of 1. And you can also change to vertical if you wanted to use up a bit less real estate. You can minimize, it'll use even less real estate. And you're able to change. Of course, that shows how I feel about maths. I heart maths. So the other thing I can do, of course, I can change that to say less than or equal to. And if you don't like the fill color, once again, you can control menu, color, fill color, and go to different color. All right, so that's relation graphing. Now, once you've got just one last thing, because we're out of time. I'll just put in a calculator page. Now, that relation, which was, I think, relation 4, it's relation for x and y are the variables. So it's given me the same thing, except in a different form. So it's basically expanded it. If I now want to see for what set of values is x equal to 1, I can use solve. So algebra, solve that relation with x equal to 1. I want to find possible values of y. I want to solve that for y. And so that's the range of values of y. So what does that mean? Let's go back to the graph. So let's put in x equals 1. So basically, where that line intersects the graph and that whole shaded region is the interval that we're seeing there. All right, now I think my time is pretty much up. So thank you very much for listening, and I hope that you got at least some useful tips from this. And just a reminder that this is only the first in a series of 6 webinars. The next one will be in a fortnight's time, Wednesday the 12th of August, on exam-style questions related to functions and their graphs. So thank you very much for listening. So goodbye, and enjoy the rest of your evening.